to go to graph. This one's open. This is already factored for us. So to take one level off, we're not going to have to factor this function because it's already factored. All we have to do is go through and say, hey, what are the zeros? And go, it's kind of nice to go from left to right just to be sure you're getting them all. X squared, the x by itself out front means 0 is one of our zeros. So I'm going to write x-intercepts. I'm just going to kind of list them here. We got 0, and should probably try that again here. So x-intercepts are 0. And we're going to look at then the next one at x plus 3 at the 0, that would be -3. What would make that 0? And what would make x minus 4 0 is 4. Okay, so those are all the zeros, x-intercepts. They're really nice to find in factored form. Just any value of x that causes the whole polynomial to be 0. Remember the zero product property, 0 times anything is 0. The next layer is not only do we want to put the zeros, but I actually right away, I know it doesn't ask for it specifically in those directions there, should, but the multiplicity is really important. So right underneath it, I'm just going to go ahead and put the multiplicity for each of these. The multiplicity of the place where I got the 0, that one was squared, and that's even. So it bounces. And then I go to -3. That one's even degreed. It's multiplicity. So that's another bounce. This graph has 2 bounces. And then the last one, when it's not written, the degree is 1. That's odd. So I have an odd degree on that one. And then with that information, I'm going to know that when I get to those zeros at 0, -3, and 4, my graph is going to have 2 bounces and a pass. Bounce, bounce, pass. And then the next question is, what's the degree of the function? It should be silly s that snuck in there. What's the degree of the function? Is not these multiplicity questions, but it's actually the sum of all the multiplicities. I want the degree of the whole thing. And so I'm going to go through, I want to put together my x squared, and then you kind of distribute the power just to the x's. You're interested only in the degree applied to those x's. So we're basically putting together an x to the second, an x to the second, and an x to the first. So essentially you're adding up all the multiplicities. So it's 2 plus 2 plus 1. The degree of this function is 5. And that's a big deal because that means and it's a positive. Notice those x's up above. I'm going to go up here and highlight that a little bit for you. If you look at these, this is a positive x squared, it will become a positive x squared. This will become a positive x to the first. So in the end, what I get is degree 5. A positive x to the 5th is the end of this one. I don't know the whole function, but I know it's x to the 5th plus a whole bunch of stuff. And that positive odd means my end behavior is fixed. So when I go to this graph over here, regardless of how everything else looks, I know that I've got end behavior like this. And you actually start there. So you start with the end in mind, the end behavior. So it's always a good idea actually starting with the end in mind in a lot of other senses philosophically and beyond. But if you start there, then we can start dealing with the sketch of this because I already know that there's zeros in this function, right? I know where they're at. I'm going to plot them. I know that they're at -3. I know that they're at 0. And I know they're at 4. Okay, and now the deal is my graph will hit those zeros. The problem is you got to make sure you hit them in the correct way. Now, the slant, how far over you put that end behavior is all the sketchy part of it. The things that are fixed are the fact that it finishes lower left down and upper right hand side is finishing up. And when I get to the 0 of -3, I know that it had even multiplicity. If you look back over to the left, and since it had even multiplicity, then it's going to bounce at that spot. So even bounces, but you have to smoothly return. And how far I return, like if my loop I'm drawing here is pretty shallow, you can make it go way down below if you want to. That's give yourself some license for creativity in there. But you want to return smoothly to the next 0, which is at x equals 0. It is also had even multiplicity if you check out over to the left. That means it's going to bounce at that 0. So we bounce there. And then finally we're going to return to the last 0 at 4. And when we get to that one, we are going to pass through because it had odd multiplicity. So it passes there. And now you can, sky's the limit. So I love the piece of this where you don't actually have some of it fixed. You could actually make those leaps, bigger. But the key is you can't have any sharp turns. It has to be a polynomial with smooth curves. All your turnarounds have to be not corners, nothing kind of rigid or straight lined. It's all smooth and transitions smoothly. Okay, describe the end behavior using limit notation. Now we have the graph over here on the right-hand side. Limit notation is one of our new skills you got to be really on top of. So the sketch, by the way, we checked off part D. We're done with that one. But let's do our limit notation on the end behavior. So every time you do limit notation, you just have to somehow memorize this. You would do limit, the x goes underneath with an arrow to some form of infinity. I always start with the left, negative infinity, and then you write the function's name, g of x in this case, I think, or is it? No, it's f of x, sorry. So let's back up a little bit. Back. There you go. My little hint thing keeps popping up, so hope that goes away someday. Thank you. And limit as x goes to negative infinity of f of x. That's this left side right here. That left, as x goes to negative infinity, as I travel to the far left of that graph, what do my y values, my f of x values, head toward? And they're down towards negative infinity. So I'm describing where the heights of my graph are going as I go to the far left. And some of you have been liking drawing in, like actually saying left and circling it. Now the right end is when the limit as x goes to positive infinity, and the x is under the limit with an arrow. Those are all notation things you need to know. And then the f of x is immediately to the right. So as x goes to positive infinity, as I head to the right, what are my y values headed toward? In this case, they're headed toward infinity. The graph keeps going up. Positive infinity. Okay, so that's one of those new notation things that's kind of still fresh in our brains, but I'm sure it's getting better. Okay, so this would be a good chance for us. I'm going to pause and get to the next page. You want to wiggle a little bit, and then I'll get right back to you with part 2, especially if I can find the stop button.